I'm going to go over some of the pencil problems for Chapter 6, Section 1, the inverse sine, cosine, and tangent functions. Before you start, make sure you have your 3 tables copied so you can refer to them while I'm going over this. I will be checking in class that you have this for your flipped assignment. Okay, the first one we're going to do is number 13. It is understood, and I don't remember if when you did logs, where it was understood that we are really seeking theta. So on these, just set these to theta. And what we're going to do is we're going to take the sine of both sides. So what I have here is the sine of both sides. And these two will cancel because these undo the operations of each other. And we have 0 equals sine of theta. Now, you look at your table, table 1, and you're going to notice that we're really looking for theta. So you look on your table and you look for 0, and you notice that theta equals 0. So sine of 0 equals 0. So your answer is theta equals 0. Okay, for tan inverse, again we're going to set this to theta. You take tan of both sides, so basically if you want, you don't have to show your work on that. You can just move tan over here and say 0 equals tan of theta. So I took away the inverse. Again, what we're doing is we're taking tan of both sides. So we get, when you take tan of both sides, these two will cancel out, and you get 0 equals tan of theta. You look on your table 3, and on table 3, you look for 0, and you notice that theta equals 0. So theta equals 0 because tan of 0 equals 0. So your answer is theta equals 0. Okay. Now let's look at sine inverse of root 2 over 2. So we're going to set this to theta and just write it as root 2 over 2 equals sine of theta. I just moved this guy over there and took away the inverse. And if you look on table 1, you know that theta equals pi over 4. Because sine of pi over 4 equals root 2 over 2. So this is your answer. Now let's try another where we had negative root 2 over 2. If you look on your big unit circle chart, you'll notice that sine of theta equals negative root 2 over 2, and theta would be 7 pi over 4. But we can't go around the circle because this is inverse. We restricted the domain between negative pi over 2 and pi over 2. That's why the table is so important. There is not a 7 pi over 4 on table 1. What you do have is theta equals negative pi over 4. So when you're dealing with inverses, it's very important to consider the restrictions on inverse functions. That's why you need to watch the video before this one. Excuse me, on the restrictions of the domain. So theta equals negative pi over 4. And we'll talk about this in class more. But when you're talking about sine, we only can deal with this area right here, which is negative pi over 2 to pi over 2. You cannot go around here. to get to this value here. You only can go down here, which is clockwise. That means when you're going clockwise, it's the negative right over here. Okay? Cosine's much easier because on cosine, we're just dealing with the restrictions are between 0 and pi, quadrant 1 and 2. So you don't have to worry so much. You could actually use your big unit circle chart on this one. All we're dealing with is between 0 and pi in this area in here. So your answer has to be one of these values. This is from table 2, so you need to have table 2 ready. So when you look at table 2 in your book, we're seeking theta, which equals, or you can set this to theta, cosine of negative root 3 over 2. When you look for negative root 3 over 2, you get theta equals 5 pi over 6. Okay? In this case, we know root 3 over 2 goes to pi over 6, so theta equals pi over 6. In this case, I just knew what I was seeking. I didn't show any work. I just knew that this was the answer by looking at the table. So if you know your tables on this and you know your radians and the chart, you can go a lot faster. These are quite easy. Basically, these cancel out, so you're just left with 0.54. And in this case, those cancel out, and we get 4 pi over 5. So this set is easy. Next set we're going to do in class. This is a very important set. We're going to be talking about the restrictions on that first video I did, and the table you really want to know. Let's see if it puts it all together for us, hopefully. Let's see if they put it all together. Nope. So you need to know, have all the yellow boxes copied, especially the ones that have to do with f of inverse of x equals x. And that means x belongs to the domain of f inverse of x. That's the domain. So you need to know all of those with sine, cosine, and tangent. You might want to really look at those because we're going to be using this information for these in class. And these will also be on your final exam as well as your unit exam.